Okay, so let's look at our third example. And I would like you to pause this video and try to do it. After that, come back and check if you are having the same thing as my own. Very good. So let's continue. A Ferris wheel. Yeah, it's always a Ferris wheel. And a Ferris wheel is like a bicycle wheel. Okay, so that's it. A Ferris wheel with radius of 24 meters. As I said, if you approach modeling with trigonometric functions question, as always go and get the moment you start to go and sketch, bam, bam, Ferris wheel, bam, 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 bam. No, you can't do it. You will lose on your own. Always take your time. A Ferris wheel with radius 24 meters. Then you go and sketch. Wow. Ferris wheel. Ferris wheel. Radius. Placed 1 meter above the ground. Oh, so that means that it's placed 1 meter above the ground. Take your time. So that is the 1 meter, and the ground will be for time per seconds. And this will be hours per minute. I love this. It's simple. Oh, let's continue. So, place 1 meter above the ground, rotate once every 24 seconds. So, what is that telling you? That means that after one revolution, alright, after one revolution, it rotates 24 seconds. It rotates 24 seconds. It rotates 24 seconds. So that means that I start from 0. As I said, the next point shouldn't be under this. It should start from here. So rotate 24 seconds. So 24 seconds, that is the time period. That is the time period. So you multiply that by 1/4, and that's going to give you 24 divided by 4. Alright. Alright, let's continue. So this is 6. Very good. So you start at 0, then you begin to add the 6. So 6 here, you get 12. 6 here, you get 18. Right? And 6 here is, so you get to 24, then you stop. 6 here, you get 24. Alright, then you stop. No, not continue again. That is one revolution. Don't continue again. That is one revolution. Very good. So the point here is 1. That of 1 here. Here is 1. Here is 24. So here is 25. 1. Okay, so here is 25. Now what is going to be here? 25 plus 24. And that's very good. And that's going to give you 49. 49. In fact, there are some people even how to write this is a problem for them. But it's not anything. Here is 1. Add to this, you get this. Add the results to this, you get this. That's all. After that, watch. You need to do this. You are just tracing the plotted points where it's going to be. Then you trace this one to this, trace this one to this, trace this one to this. That is one. Then the Ferris wheel, there's going to be a point here. 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 Oh, nicely sketched. Then you go like that. Oh, don't continue again. That is for only one revolution. Only one revolution. Then you know that here is going to be your maximum, the mean, and the minimum. I like this. That is how we do it. Very good. And that is all. That's all. What the next thing to do? The question says you have to do what? A Ferris wheel with radius of 24 meters, placed 1 meter above the ground, rotate once every 24 seconds. Passengers get on the ride at a height of 13 meters above the ground, and it starts by rising. Very good. And it starts by rising. Write a sinusoidal function that describes the height of Amma from her starting point. Alright. Alright, just forget the 13, the just annoying to the question. It's not going to affect anything, alright? So let's go for the amplitude. Now we know that our maximum, let me clean this part. The maximum is 49, the minimum is 1. So the amplitude (49 minus 1 over 2), and that's going to give you 24. Then we go for the average, which is the same as the capital D, which is 49 plus 1 over 2, and that is going to give us 25. 25. Alright, then we go for the period, because we want to go and write the equation. So that is going to be 2 pi over b. And what is going to be the b? That is 24 after 24 hours. That's for one revolution. And that is going to be pi over 12. Pi over 12. Now watch. What do you think the equation is going to be? Let's write the equation. I'm going to do that here. So what will be the equations? Let's get it first in course, okay? Now, just as what you see there, this is at origin, alright? Because you can see this, how are we going to do that? And that is for cosine, and that is just a cosine at origin, alright? In case the first question is not clear to you, second question not all that clear, and you are still not getting the third one, then we are getting to the end of it. So please, sometimes you have to even play the video about 3 or 4 times. If that is going to help you to get a concept, you can even play it 10 times. And once you get a concept, that is all. Alright. Very good. So now, play. For cos, for cosine, this is at what? Origin. But please tell me, is it going to be a negative? The amplitude, is it going to be negative or positive? You have to know that that is going to be negative, alright? So this is going to be a negative cosine, a negative cosine. And the amplitude, so you are writing h in terms of t because the amplitude is 24. So negative 24, then cos a not s t minus no. This at origin, so c is equal to 0. This is 0. This is 0, so it will learn BT. BT. So what is B? Pi of 12 T. And the vertical shape on average is plus 25. 2. Quickly, I don't want to talk much on this. Quickly, let's move on. So that is that for that. What about sine? What about sine? Now, if you want to get it in sine, you know that you can be now write there another equation for cos and MC. If you want to get it in cos again, how many shifts will you move? 3. So 1 unit, then 3 units. So you can write another one for cos, and that is going to be shaped at where t is 12. So that will be like this, alright? So you can get another one for cos, but that place will be minus 12, minus 12. But go and do that for yourself. Let me go for the sine. And that's going to be, now for sine, we have to shift to the right at where t is 6. So that will be here, and that is going to be giving you something like this, alright? And this one is concave up, alright? And since it's concave up, is it going to be positive or negative? That's going to be positive. So the amplitude this is 24 sine. There is a shape. So pi over 12. Then t minus c. And the c is shifting to 6 plus 25. Right. So that is going to give the second equation. Very good. That's going to be the second equation. Okay. So now the question says that passengers get, oh, I'm coming, not that place. Okay. Alright, so yeah, as I said, the 30 meters there is just a noise to the initial question, or that is not going to affect the graph, alright? Because we already know from the beginning that the Ferris wheel is 1 meter above. So if you move on to here 30 meters above, it doesn't mean that it's going to be 30 meters above. No. Here is where the 13 is now coming in. So let's go for that. So the person says that passengers get on the ride at a height of 13 meters above the ground. And it starts by riding. Write a sinusoidal function that describes height of armor from a starting point. So we are now going to write that. Alright, so we are looking at where armor begins riding at a height of 13 meters. So that will be after 1 meters above. So however, armor begins riding at a height of 13 meters. So we need to go and find theta, because the theta for, or the argument for where we are having 1 meter will not be equal to where we are having 13 meters. Alright? So the shifting too will change. It will also affect the shifting. So we go to find that. And that will be sin theta to be equal to 12 over 24. That is 24 revolutions. right? Which will be giving you half. That will be giving you half. And theta is going to be pi over 6. Alright, we are going to get theta to be pi over 6. Now that we have theta to be pi over 6, then we go and do the substitution to where we have the sine equation. Alright, where we have the sine equation. So, where now, as I said, it's going to affect the shift. Alright, so you for the equation for the sine, let me go back. That is t minus 6. It shifted to the right 6 times, alright? But with this, for that one, it shifted at where t is 6. But with this, the shifting is now being affected, alright? So we need to go and do the substitution of c, which is pi over, sorry, let me think. Oh, that is. We need to go and do the substitution. So we need to go and do the substitution where we have c to become the pi on 6 to the equation there. That will be the end. So 24 sine pi over 12 t minus pi on 6 plus 25. So that's all. That's all. Now we'll be looking at our last example. Let's wrap up. In a point, the time between successive high tide is 12 hours 30 minutes. The average depth is 5 meters, but at low tide is 3.8 meters. Find an equation to model the water depth at this point and use it to recommend time for a boat with a drop of 4.2 meters to enter the point. Very good. So this is the question that we have on the board. That's the question that we have on the board. So the first thing to go is the period. Now from the question it says that in a point the time between successive high tide is 12 hours 30 minutes. So that is the time period. Alright? And if that is the time period, then we have to go for it. But this is 12 hours 30 minutes. So we have to convert the 30 minutes to hours so that we can combine to get it well. Very good. Now looking at this. So we are converting 30 minutes. So if 1 hour is to, if you are using a common ratio proportion, if 1 hour is to 60 minutes, then what will correspond to 30 minutes? Alright, so that the ratio proportion, we are going to get that to be 0.5. So 0.5 hours will be the same as 30 minutes. 0.5 hours will be the same as 30 minutes, and that is half. So half of 60 is going to give you that. Very good. So therefore the period, so now we now go, since this one is now is in hours, we now go and add this to the 12, and we are going to get 12.5. So the period is going to be 12.5. Very good. And don't forget that in this period, which is 12.5, that we are going to multiply 1 over 4 by 8. Okay? We want to get the interval we are going to go back. Very good. So let's go for the b. So that's 2 pi over b. Alright? So the period, so we go for that, that is 2 pi over b, and that's going to be 2 pi over 12.5, and that's going to give you 4 over 25 pi. So 4 over 25 pi is going to be the b that is going to be in the question. Okay? Now, when you look at the question again, we are given that the average depth is 5 meters. And don't forget, the average is the same as the vertical shift. And if that is the same as the vertical shift, that means that the capital G is going to be 5. Alright. But at low tide, so the low tide is also given to you at 3.5. And the low tide here is going to represent the minimum. The low tide is going to represent the minimum, and that is 3.5. Alright. But don't forget that you have the average. So if you have the average, this is another method to find the amplitude. If you have the average and the minimum, you can subtract the minimum from the average, and that's going to give you the amplitude. That is another way to go for the amplitude. Alright. And after getting the amplitude, to get the high tide, don't forget that we know the low tide, but in the question is silent on the high tide. But you can get the high tide by adding the amplitude to the average. By adding the amplitude to the average. And now we have the high tide, which is the maximum to be 6.2. Now, if you want to verify that this is another method to get for the amplitude, you can now go and add 6.2, or you can now go and subtract 6.2 from the minimum, which is 3.8, and divide by 2. So I'm going to get the same answer to be 1.2 for the average, for the amplitude. So that is that for that. Alright, so let's go and write our equation. And lastly, we draw for the graph. But let's look at something here. Find an equation to model the water depth at this point and use it to recommend time for a boat with a drop of 4.2. So this is telling us something and we'll be looking at it. But let's first go for the equation. Right? So having this, then the equation will be simple for us. I can create the equation now. So the equation is going to be h of t, which is equal to the amplitude, alright? The amplitude. And the amplitude, that's going to be 1.2 cos 4 pi, that is 4 pi over 25. And it's going to be at the origin. You will sketch it and you see it's going to be at the origin plus 5. Alright, so that is going to be the equation. That is going to be the equation. Now the question is saying that we have to use, the question is saying that we have to find the equation, model the water depth at the point, and use it to recommend time for a boat with a drop of 4.2. So this is telling us that h of t is equal to 4.2. Alright. So you get to the substitution. So here is 4.2 to be equal to 1.2 cos 4 pi over 25. Oh, sorry, t. 25t plus 5. So all that we are doing here is that we have to go and find for t, and that is the time. That is what we are going for. 8 for now. Very good. But I will leave that for you to continue it yourself to find the t. It's not anything difficult. You can send this one to this side. So you get 1.2 cos 4 over 25 pi t is equal to, so you send this to this side, so that is going to be 4.2 minus 5. Alright, so whatever you get, you divide by 1.2. So you get cos 4 over 25 pi t is equal to, and when you subtract, you get negative 0.5. negative 0.8 rather, negative 0.8. Then you divide this result by this 1.2, and you are going to get cos 4 over 25 pi t to be equal to, this is going to give you negative 0.6, negative 0.667. Alright. Then you take the cos inverse of both sides. Take the cos inverse of both sides, you get 4 over 25 pi t to be equal to cos inverse of 0.667. Alright. And with that, the cos inverse of this. Now 4 over 25 is the same as 0.5. And this is going to be equal to, so pi t. I'm coming, let me do the right thing. Oh yeah. Right. So this is 4 over 25 pi t is equal to, now the cos inverse of this is going to give you 0.841. Alright, so we are applying for t, but when you put this on calculator, 4 over 25 times pi, which is the same as 180, pi is the same as 188. You're going to get 0.5 t is equal to 4. Then we go for t, so t will be equal to 0.841 over 0.5. And lastly, you're going to get t to be equal to, I'm going to get t to be equal to, okay, so you're going to get t to be equal, so this is going to be black or minus, alright, it's going to be equal to black or minus 3.14, 3.14 pi. Very good. So you end up getting, you know that 3.14 is pi, alright. So you end up by getting t to be equal to 4.602 or 7.966. Alright, so follow the procedure and get for the t. So that's going to be your time for that. Let me give you the graph. Let me give you the graph to close for this. You can see that I'm very tired in the video. You can see that. So let me give you the graph for us to close. For modeling with trigonometric functions, but don't forget our project about more than 10 questions and at this topic for you to go and exercise it yourself. Very good. So we know that the high tide is 6.2. We know the average is 5. Then we know the low tide. The low tide, that is 3.6 or 5, 3.5. Very good. So I'm going to be the high tide. And the average. So time per second. Very good. So now with this, this is the period. You multiply by 1 over 4, and that's going to give you 3.13. 3.13. So you start at 0, then you begin to add 3.13. The next will give you 6.25. The next will give you 9.36. The next will give you 12.5. Very good. So you start crossing it, crossing it, crossing it, crossing it. Very good. So you can see that you're going to get this, that, and that. And you're going to get that and that. So your graph is going to be like this. Wow. So that's going to be the graph. So this one is a cosine graph, and you can see that it is at origin. So with this, there is no shift with this. There is no shift. There is no shift. The C is 0. If you want to write the equation in sign, then you shift to the right of this and you get the sign here. You get a sign here. Or you can see that that will end here. Okay? And you can get another cos here, whereby when you shift to this, you're going to get another cos and that will end here. And you can get another sign here, but that will go one, that one will go like this. Or you can see that end here. So that's how we do it. Thank you for modeling with trigonometric functions. It's not easy, but please keep on practicing, okay? You can watch the video about 10 times, and if your concept is there, no matter the questions that you read, you can be able to solve it. Alright, please, I would like you to subscribe to our YouTube channel. Just go to YouTube, type math expert. Whether you add n to the mass or you don't add n to the mass, it will show up. Or whether you combine the mass and the expert, it will still show up. Just type math expert and subscribe to our channel. In fact, we have a lot for you. This is just the beginning. Thank you and see you in the next video. Now in the next video, what are we going? What are we actually going for? Okay, that would be trigonometric identities and equations. Alright. In fact, that one too is going to be interesting. Thank you. See you. Alright, so that's going to be the solution to the fourth question. So, what come back? Check if your amplitude is correct, if your D is correct, and the graph is the equation. Alright, thank you. Now, I would like to add one more question to it. I would like to add one more question to it, and that is going to help you to build your concept under modeling with trigonometric functions. So that is that for the solution for the fourth one. See you for the question 5.
All right, so I would like you to solve these questions on your own. The question 21 here, the 22, the 23, then 24, okay, and the 24. And let me see if I can get some to add here for you. All right, so let's add this one to it. This one is from question 10, a population of whatever. So do that one, the question 10, the question, oh, the question 11, 12, the question 12, the question 13. Let me show it to you well so that you can pause the video and write the question 13. Okay, we have the 14, 15, 16 up to 18. All right, so make sure you try on them and it's going to help you. In case you don't understand anything, you can email me or send me a message through WhatsApp. Thank you and see you in the next video. All right, bye-bye.